In this video, we're going to focus on foiling binomial expressions using Pascal's triangle, and also how to find the coefficient of, let's say, the fourth term or the seventh term, and things like that. So let's say if we have the expression x minus 2 raised to the third power. How can we FOIL this expression? Now there's two ways you can do this. You can multiply x minus 2 3 times, or you can use the binomial theorem to help you to expand this expression. We're going to do it both ways. But first, let's use the binomial theorem, and then we'll confirm the answer by actually foiling these three terms. So you need to be familiar with Pascal's triangle. So let's start with a 1, and then let's place two other ones. 1 plus 1 is 2. At the end, you will always have a 1. 1 plus 2 is 3. 1 plus 3 is 4. 3 plus 3 is 6. Hopefully by now you see a pattern. 1 plus 4 is 5. 4 plus 6 is 10. And so forth. Now, notice that we have an exponent of 3. So we want to use this rule where the second number is 3. So the coefficients that will be useful to us are 1, 3, 3, and 1. The coefficient for the first term, it goes in order from left to right. It's 1. And then we're going to have the first letter, x, raised to the third power. And then the second part of the binomial, which is negative 2, and it's going to be raised to the 0 power. Now, these two exponents must always add to 10. I mean, not 10, but must always add to 3, this particular number. Now, the next term will have the second coefficient of 3. Now, this exponent will decrease to 0, and this exponent will increase eventually to 3. So this is going to be 2, and the next one is going to go up to 1. Now the third term will have a coefficient of 3. And then the exponent associated with x is 1, and the exponent associated with negative 2 is now 2. And then the last term will have a coefficient of 1. X will have a power of 0, and negative 2 will now have a power of 3. So that's how you can use the binomial theorem. But now let's simplify the expression that we have. Anything raised to the 0 power is 1, so we could ignore this value. So the first term is simply x cubed. Now what about the next one? 3 times negative 2 is negative 6. So it's negative 6x squared. Negative 2 squared, that's negative 2 times negative 2, that's 4. Times 3 is 12. So we have 12x. And now the last term, negative 2 to the third power is negative 8. And x to the 0 is 1, so this is simply negative 8. Now let's confirm the answer by foiling x minus 2 3 times. So what we're going to do is FOIL the first two terms. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is also negative 2x. And finally, negative 2 times negative 2 is positive 4. Now we can combine the middle terms. Negative 2x minus 2x is negative 4x. So now let's multiply the trinomial by the binomial. So x squared times x is x to the third power, and x squared times negative 2 is negative 2x squared. And then we have negative 4x times x, which is negative 4x squared. And negative 4x times negative 2, that's positive 8x. And then 4 times x is 4x. And finally, we have 4 times negative 2, which is negative 8. So now let's combine like terms. Negative 2x squared minus 4x squared adds up to negative 6x squared. And 8x plus 4x adds to 12x. So we do indeed get the same expression. So using the binomial theorem, it can help you to FOIL difficult expressions. So let's say if you want to expand this expression 2x plus 3y raised to the 4th power. You can multiply it 4 times, or you can use the binomial theorem to expand it for you, which is a lot easier. So let's go ahead and do this.